cleanroom or cleanroom is an environment, typically used in manufacturing or scientific research, with a low level of environmental pollutants such as dust, airborne microbes, aerosol particles, and chemical vapors. More accurately, a cleanroom has a controlled level of contamination that is specified by the number of particles per cubic meter at a specified particle size. To give perspective, the ambient air outside in a typical urban environment contains 35 million particles per cubic meter in the size range 0.5 AI 1/4 m and larger in diameter, corresponding to an ISO 9 cleanroom, while an ISO 1 cleanroom allows no particles in that size range and only 12 particles per cubic meter of 0.3 AI 1/4 m and smaller. History: the modern cleanroom was invented by American physicist Willis Whitfield. An employee of the Sandia National Laboratories, Whitfield created the initial plans for the cleanroom in 1960. Prior to Whitfield's invention, earlier cleanrooms often has problems with particles and unpredictable airflows. Whitfield designed his cleanroom with a constant, highly filtered airflow to flush out impurities. Within a few years of its invention in the 1960s, Whitfield's modern cleanroom had generated more than $50 billion in sales worldwide. The cleanroom eventually entered the hospital industry in the United Kingdom, primarily in hospital pharmacies. Overview: cleanrooms can be very large. Entire manufacturing facilities can be contained within a cleanroom with factory floors covering thousands of square meters. They are used extensively in semiconductor manufacturing, biotechnology, the life sciences, and other fields that are very sensitive to environmental contamination. The air entering a cleanroom from outside is filtered to exclude dust, and the air inside is constantly recirculated through high-efficiency particulate air and/or ultra-low penetration air filters to remove internally generated contaminants. Staff enter and leave through airlocks, and wear protective clothing such as hoods, face masks, gloves, boots, and coveralls. Equipment inside the cleanroom is designed to generate minimal air contamination. Only special mops and buckets are used. Cleanroom furniture is designed to produce a minimum of particles and to be easy to clean. Common materials such as paper, pencils, and fabrics made from natural fibers are often excluded, and alternatives used. Cleanrooms are not sterile. Only airborne particles are controlled. Particle levels are usually tested using a particle counter and microorganisms detected and counted through environmental monitoring methods. Some cleanrooms are kept at a positive pressure so if any leaks occur, air leaks out of the chamber instead of unfiltered air coming in. Some cleanroom HVAC systems control the humidity to low levels, such that extra equipment is necessary to prevent electrostatic discharge problems. Low-level cleanrooms may only require special shoes, with completely smooth soles that do not track in dust or dirt. However, for safety reasons, shoe soles must not create slipping hazards. Access to a cleanroom is usually restricted to those wearing a cleanroom suit. In cleanrooms in which the standards of air contamination are less rigorous, the entrance to the cleanroom may not have an air shower. An anteroom is used to put on cleanroom clothing. Some manufacturing facilities do not use fully classified cleanrooms, but use some cleanroom practices to maintain their contamination requirements. Airflow principles: cleanrooms maintain particulate-free air through the use of either HEPA or ULPA filters employing laminar or turbulent airflow principles. Laminar, or unidirectional, airflow systems direct filtered air downward in a constant stream towards filters located on walls near the cleanroom floor or through raised perforated floor panels to be recirculated. Laminar airflow systems are typically employed across 80% of a cleanroom ceiling to maintain constant air processing. Stainless steel or other non-shedding materials are used to construct laminar airflow filters and hoods to prevent excess particles entering the air. Turbulent, or non-unidirectional, airflow uses both laminar airflow hoods and non-specific velocity filters to keep air in a cleanroom in constant motion, although not all in the same direction. The rough air seeks to trap particles that may be in the air and drive them towards the floor, where they enter filters and leave the cleanroom environment. Personnel contamination of cleanrooms: in the healthcare and pharmaceutical sectors, Control of microorganisms is important, especially microorganisms likely to be deposited into the airstream from skin shedding. Studying Cleanroom microflora is of importance for microbiologists and quality control personnel to assess changes in trends. Shifts in the types of microflora may indicate deviations from the A-or norm such as resistant strains or problems with cleaning practices. In assessing Cleanroom microorganisms, the typical flora are primarily those associated with human skin, although microorganisms from other sources such as the environment and water are also detected, although in lower numbers. Common bacterial genera include Micrococcus, Staphylococcus, Corynebacterium, and Bacillus, and fungal genera include Aspergillus and Penicillin. Cleanroom classifications. Cleanrooms are classified according to the number and size of particles permitted per volume of air. Large numbers like Class 100, or Class 1000 refer to FEDSTD209E, and denote the number of particles of size 0.5 AA micrometer or larger permitted per cubic foot of air. The standard also allows interpolation, so it is possible to describe, for example, Class 2000. A discrete particle counting, light scattering instrument is used to determine the concentration of airborne particles, equal to and larger than the specified sizes, at designated sampling locations. Small numbers refer to ISO 14644-1 standards, which specify the decimal logarithm of the number of particles 0.1 AA micrometer or larger permitted per m3 of air. So, for example, an ISO Class 5 Cleanroom has at most 105 particles m3. Both FS209E and ISO 14644-1 assume log-log relationships between particle size and particle concentration. For that reason, zero particle concentration does not exist. The table locations without entries are non-applicable combinations of particle sizes and cleanliness classes, and should not be read as zero. Because 1AM3 is about 35 AFT3, the two standards are mostly equivalent when measuring 0.5 AA micrometer particles, although the testing standards differ. Ordinary room air is around Class 1 million or ISO 9. US FED 209 Sautome and Principe d'Aubrasie Cleanroom standards. US FED 209 Sautome and Principe d'Aubrasie was officially cancelled by the General Services Administration on November 29, 2001, but is still widely used. ISO 14644-1 Cleanroom standards, BS 5295 Cleanroom standards, BS 5295 Class 1 also requires the greatest particle present in any sample cannot exceed 5 I1/4 m. GMP EU classification, see also. Air Quality Index, Data Recovery Lab, Secure Environment, ISO 14644, ISO 14698, Contamination Control, Pneumatic Filter, Air Ionizer, Semiconductor Device Fabrication. References. External links, Cleanroom Wiki, the Global Society for Contamination Control.